Welcome. This is Glenn, and you're listening to Wild Earth Conversation. Wild Earth Conversations is about engaging thoughtful individuals in meaningful conversations that connect their interests and insight to the vision of a thriving and beautiful planet. My guest today is Alana Dodero. She is a PhD candidate in the Department of Atmospheric Sciences at Texas A&M University. For the past 3.5 years, she has been conducting both laboratory experiments and field measurements to better understand air quality and how human-made pollutants impact climate and public health. Examples of her work include measuring concentrations and emissions of chemical products in the Houston area, examining how nanoplastics in the atmosphere influence health, and currently she is investigating how industrial hazardous air pollutants affect low-income communities in order to identify where more regulation may be needed. Welcome, Alana.
Thank you, Glenn. I'm excited to be here.
Would you like to make some introductory comments?
So as you mentioned, I'm getting my PhD in the Atmospheric Science Department at Texas A&M University. My research is focused a lot on atmospheric chemistry, particularly looking at air quality, how it affects both the environment, the climate, and human health. And before I was really diving into the more esoteric side of things, I was growing up here in Grand Junction, which really is a special place where you can really be immersed in nature. And as a kid, I had a lot of curiosity about, how does all of this work and what is the role that we play in this and how can we do better to protect our planet and make it better for the next generation and so on. And, as a kid, I really wanted to solve climate change in air quotes. But as you learn more about this, you see that there's obviously a lot more nuance to issues like this when it comes to both the scientific side of things and also the policy and societal side of things. And this really kind of led me into atmospheric sciences, which is really this cool intersection of more technical areas of math, physics, chemistry, meteorology, but also has the environmental justice aspect there as well. And in this field, we can look at the large scale of things, understand climate change, our role in that, and also dive more into small scales and look at pollution in cities, how certain neighborhoods are being affected more than others, how, certain neighborhoods and certain individuals are affected more than others. So, today I'm pursuing my PhD. I'm a PhD candidate, again, in atmospheric sciences, and I focus a lot on anthropogenic or man-made pollutants and their impacts. And I'm focusing on understanding their trends and in order to better inform policy. So I've done a lot of work in Houston, which really provides a cool, interesting landscape when it comes to air quality. So it's the 4th biggest city in the country and also has a lot of industrial impacts. So we'll see various emissions from all types of compounds in these areas. And through this work, I've had a lot of opportunity to actually connect with community members in these areas that are more heavily impacted by the industrial pollutants and determine kind of measurement strategies in order to look at atmospheric compositions in these areas to understand the impacts both to these community members and then also the more secondary impacts on broader scale. But overall, in my research and also looking forward, I am overall really excited to see how things are evolving. I think these days it's really easy to get discouraged when it comes to environmental discussions. But, in terms of air quality, we've been kind of surprisingly triumphant, and we continue to see improvements being made. We had the Montreal Protocol in the 80s, which was probably the most successful global environmental agreement, where I think 200 countries came together to ban the use of certain compounds that were forming the ozone hole. And now today we see that the ozone hole is closing up and becoming less of a problem. Similarly, we make advances every day in terms of our vehicles, the emissions that we're producing. So that's kind of where my goals are, is kind of to continue that trajectory, continue to make improvements, and make a better environment for ourselves and for the future as well.
Okay, thanks for the intro. I read 2 of your scientific papers, one on volatile chemical products and the other on nanoplastics. I will begin by asking you a few basic questions, not to test the science, but to help our audience understand what you found and why it matters. So my first question, for listeners who've never heard the term volatile chemical products, what are they and where do we encounter them in daily life?
Yeah, great. That's a good question. So volatile chemical products are kind of a subset of different compounds that we emit that are traditionally coming from more consumer products. So traditionally, in previous decades, when you looked at the total anthropogenic emissions, a lot of those were coming from combustion-related sources, so vehicles or industry. And now we're seeing that as we've had improvements with vehicles and we have catalytic converters and all of these things, now we're seeing that in urban areas, the dominant emissions are actually coming from these volatile chemical products. And these are compounds that are coming from things like personal care products, deodorants, fragrances, also paints and glue, kind of things that you use more in a household sense, also pesticides. And so could be used on an industrial scale, like for construction and things like that, but compounds that aren't tied to the traditional like combustion-related sources.
Okay. When people think about air pollution, they usually think of cars and factories. Why should we be thinking more about household products and plastics?
Yeah. So that's kind of a exciting area in this conversation, is that what we consider to be contributing to our air quality is continuously evolving as we change our policies and regulations. So, for example, I mentioned the ozone hole. That was caused from compounds called CFCs, which are found in refrigerants and hairspray and things like that. And we saw that they were super damaging to upper level stratospheric chemistry, and we're depleting ozone. And then similarly, when you look at today, we're interested in volatile chemical products, for example, because they have more potential to be reactive in the atmosphere. So they can go on to form secondary products such as ground level ozone, which is harmful to our health, along with secondary aerosols, which can have impacts both directly on our human health, but then also on climate interactions as well. So that's something that we look at, is not just what are these different things in the atmosphere, but what is the role they play in terms of reactivity? Are they going to go on to form secondary things that will have impacts on us. And we see that compared to traditional combustion-related compounds, that volatile chemical products are more reactive, so will have more potential to go on to form secondary products. And then in the case of micro and nanoplastics, this is just kind of a emerging area of research that is pretty much due to the fact that they're becoming more and more ubiquitous. We're seeing them in all types of environments. We've seen that microplastics can undergo long-range transport. We've detected them in remote areas, in the Alps, in the Arctic, all over the world. We've seen them in our own bodies, accumulating in organs. So right now, I think the area of research there is just trying to understand more of what are these guys doing, because they are so ubiquitous in the environment.
Okay. So is most indoor air pollution actually more polluted than outdoor air? And if so, why is this?
Yeah, that's a really good question. So my lab and my research focuses a lot on outdoor air, but indoor air is definitely a hugely important area to understand, as we do spend the majority of our time indoors. And so that question has some kind of nuance to it. So depending on what you're doing inside, depending on like the type of building and the ventilation that you have, indoor air can be worse or better. So, for example, we will see much higher concentrations of compounds related to cooking or cleaning inside than outside, that can be harmful potentially, especially when looking at like cleaning products. And, that's something that a lot of researchers are working on, is what is the best way to ventilate and do these things. So when you're cooking, you should open a window, turn on the fan. Similar, when you're cleaning, you should ventilate your space. But we have seen that, like even low-cost air purifiers and things make a big difference. So if, for example, you're in an area where there's forest fires and the air quality outside is really bad, your air quality inside will certainly be better, and it will be significantly improved with even just a low-cost air purifier.
Okay, before I ask you the next question, take a moment, if you would, and distinguish between plastics and nanoplastics.
Sure. So that's just kind of based on the size. So plastics are just all things made of plastic. And then microplastics are plastics within micrometer scale. And then nanoplastics are those under 1 micrometer.
What surprised you most when you first began studying this kind of pollution?
I guess the thing that's probably surprised me the most is how the field is truly constantly evolving. So in my research, I'm working a lot with instrumentation, where we're going and measuring the composition of the atmosphere, and also doing more lab experiments and things like that. But even in the last 5 years, we've seen significant improvements in our instrumentation that allow us to measure hundreds of compounds in the atmosphere, compared to 20 years ago when that was just not really possible. So I think it's a field that's growing both with how we're choosing to regulate and monitor things, but also just with our advances in instrumentation.
How are cleaning products or personal care products, how do they end up in the air we breathe?
Yeah. So I guess a good way to understand this is, like if you can smell it, it's in the air. So when you're spraying a cleaning spray, a multi-purpose cleaner or whatever, you can smell it. So that means that these compounds are being emitted. Similarly, you open a can of paint, you can smell that. So if you can smell it, that suggests that the concentrations are actually pretty high. And then there are even lower trace concentrations that you can't detect with your nose, but then now again with advancements in instrumentation, we can detect sub parts per trillion levels of these different compounds.
Are there pollutants, or are these pollutants short-lived, or do they linger in the air for long periods of time?
Yeah, that's a good question. And again, kind of has some nuance. So depending on the compound itself, depending on its chemical structure, how reactive it is, they'll have various lifetimes. So a lot of the volatile chemical products will have lifetimes from a day to maybe 5 days, which will depend a lot on meteorology patterns and things like that. If they're being transported or if they're being deposited onto surfaces, if they're inside or if they're outside. But then some compounds also have potential to be much longer lived. PFAS are a class of compounds that are gaining a lot of attention right now. They're found in a lot of like Teflon pans, our waterproof jackets, things like that. And they have been found to be toxic, and also due to their chemical structure, they're not very reactive, so they can remain in the atmosphere for much longer periods of time. Now, when looking at microplastics and nanoplastics, we've seen that, again, they can undergo long-range transport, be transported from industrial or metropolitan areas to more remote areas, and they can have lifetimes up to potentially like 30 days. So it really depends on the chemistry that's going on there. And that's something that we need to be considering when we're deciding what types of compounds we're using in different products, if they're going to be around for a while and have more impacts later on, or if they're shorter lived, and all of these things. Yeah.
How does plastic become airborne pollution?
Yeah. So a lot of this is due to how we deal with plastic. Very little of the plastic that we produce is recycled. So a lot of it has the potential to degrade in the environment, whether that be in the ocean, in the water, or just in the environment in general. So it can be emitted through like sea spray, but the biggest source of it is just from burning trash. So we have, in the United States, we do this. We incinerate plastic, whether it be intentional or accidental. And then globally, especially in like Southeast Asia, where a lot of the plastic that's produced is sent, the trash incineration is the main way to remove it. So obviously that's creating a lot of these tiny particles that are then have potential to be emitted into the atmosphere.
What do we know so far about how these airborne chemicals and plastics affect public health?
Yeah. So again, this is a pretty new area of research. So the second paper that I did was looking at how a specific type of plastic, so this is polystyrene, which is found in styrofoam, food packaging, how this impacts human health. But there's also many other types of plastics. There's PET, which comes from like water bottles, which is probably the most common. There's also nylon, which is in your clothes, PVC in pipes, things like that. So research is still being done in various areas looking at how this affects humans, how this affects ocean organisms and all of this. So it's dependent on the type of plastic and probably what system you're looking at. But for my research, we did see that when we kind of replicate how plastics degrade in the atmosphere through oxidation, so we call that atmospheric aging, with increased aging or oxidation of these particles, they do become more, they produce more of a stress effects. Let me say that again. So when these plastics become more oxidized or more aged, they have higher effects on stresses and inflammation than the unaged or pure plastics. So for this research, we were trying to kind of represent more realistic situations, and saw that they increased oxidative stress and inflammation, but didn't increase toxicity per se, but still could lead to problems.
In addition to respiratory effects, which I got from reading your paper, do these pollutants affect the brain and the nervous system?
Yeah, so again, that's pretty ongoing research. We have seen that they are detected in brain tissue, in blood, throughout our bodies, really. But currently, understanding if they have potential to form tumors and things like that, that's still definitely ongoing. But again, I think from the research that exists, we see that certain plastics definitely have more of a response in our genes than others. So I think moving forward, we'll hopefully see that we're making products out of different types of plastics based on our understanding of how they're affecting us.
Once these chemicals and plastics are in the air, where do they end up?
They can, again, undergo transport and be moved across the globe. Oftentimes, they are just deposited. They fall out because they're relatively large particles. Some research is going into understanding the role they play in terms of cloud formation, because they are aerosols, and aerosols are needed in order to form clouds. Some of that work has been done in my lab as well. And overall, we're seeing that they're not really great at cloud formation. But yeah, so I think most of them will fall out pretty quickly after they're emitted. But the smaller particles do have the potential to be transported globally into your homes, into water, and so on.
What are the big unknowns in your field of research?
Yeah, I mean, there's a lot.
How about the one that's maybe the most dangerous or threatening or scary?
Yeah, I think, let's see. So I guess that's another thing where the improvements in our measurement techniques really come in. So now we're able to measure far more compounds than we could. And often when I'm doing research, I'm looking for specific compounds that I know. So I'm looking for benzene, that we know to be toxic. I'm looking for these volatile chemical products that we know are prevalent. But then there's also compounds that we don't know about, that we call more of a non-targeted analysis of looking for things that we don't really know exist. So that is something that's definitely an unknown if you don't know it exists. And then also, I guess, the role that different sources of pollution are playing. So recently we've seen that cooking actually plays a really big role, especially in metropolitan areas, to overall emissions. So yeah, seeing, what types of where compounds are coming from too is also a bit of an unknown.
I think I know the answer to this next question, but I'm going to ask it anyhow. Are safety regulations keeping up at all with what science is discovering?
So I think this is a little bit of, it's tricky because connecting science and policy overall can be sometimes slow. But something that I've been very impressed with is, working in Houston, we're in a lot of these very industrial areas, and these companies, they do have their own like fence line monitors around their facilities to determine if there's leaks or if there's any exceedances of these certain compounds. So for that, I'd say that the policy is there and we can continue to improve on it.
Are there practical steps people can take in their home to reduce their exposure without becoming obsessive?
Yeah, of course. Yeah, again, when it comes to like cooking or cleaning, ventilating your home is important. Also, just ventilating here and there is good. Open your windows every once in a while, and that's not really a big to-do or anything. Also, just be aware of how many products and things you're using. And, for example, bleach is a big one that we see. It has a lot of emissions that can be harmful to our health. So just be cautious or just pay attention to, like how often you're using these products. Do you actually have to be using them, etc.? Obviously, you need to clean your house. But yeah, I think the ventilation thing is a big one. And then similarly, just low-cost air purifiers can make a huge difference in terms of particulate matter concentrations and things like that. So especially in the West where we have all these forest fires and things, I think that's definitely a reasonable thing to have.
Are green or natural products actually safer, or is that mostly just marketing?
I can speak on this in a few ways. I'm not fully knowledgeable about like if you were to take a green all-purpose cleaner versus your name brand all-purpose cleaner. I think the thing typically is that the green products have fewer ingredients, so we'll have fewer chemicals that are being emitted. When it comes to the plastic side of things, we're seeing an emergence of kind of these bioplastics and things like that. But similar to, our traditional plastics, we do see that these are still very long-lived. They still have the potential to be broken down, emitted into the atmosphere. And as this is still ongoing research, we aren't 100% certain, but we are seeing that there is, similar to other plastics, still the same potential to impact with climate and our health as the others as well.
What kinds of changes would make the biggest difference? Policy changes, changes in industry, or consumer behavior?
Yeah, I think there's really not just one solution fixes all, and really it has to be a collaboration between all three of those. The policy will obviously impact industry, but consumer behavior also impacts industry as well. So, especially when it comes to the plastics, that's just a big thing of consume less, produce less waste, don't drink plastic water bottles, which is easier said than done in certain areas, obviously, depending on where your water is coming from and things like that. But I think being more informed about all of these how these different products that we use can impact ourselves, we've seen in the past can definitely kind of change what types of products we're using. So I think the personal level is definitely important here as well.
If you could change one assumption that people have about pollution, what would it be?
I guess that would be that, pollution is just kind of one thing. It's just this primary, the things that are directly emitted from the smokestack, things that are directly emitted from a forest fire. But really, there's a lot of complex chemistry and things that are happening in the atmosphere where we're seeing that these primary emitted compounds can actually form secondary compounds, that those can be transported, and those can have their own unique impacts on our health and on climate. So it's not just this, one compound. And similarly, when looking at the smokestack, there's hundreds of compounds being emitted from it. It's not just benzene that we're super scared about, but there's a lot of different compounds coming into play there.
What gives you hope as a scientist working on these issues?
Yeah, I think I kind of touched on this in my introduction, but in this area, we have seen a lot of improvements, although we may sometimes think they're slow or anything like that. If you compare air quality now to air quality even 20 years ago, it's significantly better. If you go to the LA basin, you can actually see now, whereas it used to be just smoggy, blech. So we are making improvements, and we are seeing that reflected directly, relatively quickly. Like, we've made improvements with our vehicles, and since then, now, like, the air quality in our big cities is significantly better than it was 10, 20 years ago. So,
is that true worldwide? Do you know?
I think when we look at European countries, United States, we see a lot of improvements there. When you look at more developing countries, I think that changes a little bit different. But also there's just kind of a different lifestyle, I guess. So, like, we focus a lot on driving and things here. Whereas the pollution in New Delhi, for example, is much different than the pollution that you'd find in Denver or Houston. But I think overall, research that we do here in the U.S. or in Europe is hugely beneficial to other countries as well. And they can see, like, oh, if we do this, we'll see an improvement, or we should not use this compound in this certain thing because it leads to all these problems. So yeah, I think there is definitely this global participation element of that is promising.
I'm sure people underestimate how much their everyday routines shape the air they breathe. Do you think this is due in part to the fact that there's a disconnect between how clean something looks and how clean it actually is?
Sorry, can you elaborate on how clean something looks?
Well, maybe one of the reasons we don't think too much about what we're doing to the air we breathe is that the air still looks pretty clean, even though we're using all these chemicals.
Sure. Yeah, sure. I mean,
more of a comment than anything, I think.
Yeah, I mean, obviously, it's hard to understand something that you can't see, and I mean that's a huge difficulty in the sciences. Is trying to explain these more esoteric things to the general public, but I think that's kind of a a duty of scientists is to be able to actually convey this information more so that people can actually understand it and understand that, yeah, putting on deodorant emits things into the atmosphere, right? And that can have various effects. And I think we've seen that in terms of certain pollutants, like microplastics right now are getting a lot of attention, I think, which is pretty new in the last year or so, just because, people have been talking about it and explaining this in a more layman's terms and that. So, yeah, I think that people are more than capable of understanding and connecting to this. It's just a matter of conveying that information effectively so that, it resonates with people.
Okay, I do have some questions about the duty of the scientist. But before I get to those, I just want to say that since this show, Wild Earth Conversations, is about the health and well-being of the Earth and about new and better ways of human beings relating to the Earth, let me ask you some questions directly related to this topic. Without getting into technical details, how is your work related directly or indirectly to global warming?
A lot of global warming, is caused by greenhouse gases. We've heard about CO2 forever, right? And so a lot of these different compounds have potential to cause warming, and then also can have potential to form secondary products like aerosols that can also either absorb or reflect sunlight and also cause warming as well. So yeah, understanding all of these and helping that kind of play into regulations and things like that is definitely important here.
From your research, or from what you have learned from others, is there any place on Earth that is truly isolated from airborne pollutants? Are the most remote wilderness areas being altered and harmed by air pollution?
Yeah, so, the Earth really is interconnected. We see that a lot of what we produce does have potential to be transported long distances all around the world, even to remote areas, probably in very low concentrations or whatever. But again, going back to the ozone hole, that formed in Antarctica and in the Arctic from refrigerants and hairsprays. So obviously in Antarctica, they're not using those, but these compounds undergo transport and ended up there. On the harm side of things, that's very dependent, again, on, what compounds actually are. We see microplastics in, the Arctic and the Alps, but are they really playing a huge role? That's still kind of up for discussion and up for we need to learn more about that. But yes, I think when thinking about your air quality emissions, it is important to understand that it doesn't just impact your city. It doesn't just impact your town. It has the potential to impact the entire world, really, especially in larger metropolitan areas where there's just more emissions.
Is there research being done on how wild animals are exposed to airborne chemicals and plastics?
Yeah. So in terms of plastics, a lot of research is done in more the aquatic ecosystem because we have detected them in water. That's probably the first place that they were really measured. So a lot of more toxicological studies, biology studies are looking at water and sea life and how they're being impacted.
That's why I asked about airborne chemicals, because I'm familiar with some
Yeah.
of that.
Yeah, and then so in terms of airborne chemicals, yes, I think in terms of my research, we don't do that too much, but there are definitely people working on this. Yeah.
Could the measuring devices and other technologies you used in studying air pollution in the greater Houston area also be used to study small and medium-sized non-human critters that also live there?
Yeah, of course. Because we're studying air quality as a whole, so the air that we're breathing is the same air that any other critter that's living there is also breathing. And similarly, in that vein, a lot of work that we do focuses on these metropolitan areas because, that's where the majority of people live. But other work has also been done to look at more remote areas and understand that, like these instruments can be moved. We put ours in a van and drive it around.
Yeah,
So
I read that.
there is definitely potential to do similar research in all different types of ecosystems and areas.
Once these pollutants settle out of the air, how do they move through ecosystems?
Yeah, so some can definitely enter into bodies. They can bioaccumulate. In terms of a lot of the gases, we see that those often, they have a certain lifetime. They'll react and essentially go away. But they can have potential to enter into water and soil and things like that after they're in the atmosphere.
So you may have already answered this question, but I'm going to ask it again. Are these pollutants contributing to biodiversity loss? And are there people working on this specific issue to your knowledge?
To my knowledge, yes. There are people definitely looking at, are different species more prone to, getting diseases or things like that from various different pollutants. It's not my exact area of expertise. But yeah, I would think that different species will definitely have different responses to varying pollutants and also varying levels of pollutants. And also just like the overall exposure. So how much over a certain amount of time? Is it your whole lifetime that you're being exposed to these things? Or are you just exposed for an hour? All of these things also play a role in that.
So acid rain is still a big problem globally. I know that it is still damaging the Adirondack National Park, as well as large parts of Central Europe and even Arctic wildlife. So could you speak to that?
Yeah. We have seen a decrease in acid rain in the United States with the Clean Air Act as we've decreased, coal production and these compounds that are more sulfur containing, they will go on to kind of react and form this acid rain. So yeah, it often comes from coal production, combustion, related emissions. So we have seen decreases, but as many places in the world are still burning and relying on coal and other burning fuels, acid rain is still definitely a thing. But we have seen that with increased regulations on these emissions that it is possible to decrease its effects. So I do anticipate that will be the case in the future.
Okay. Do and can scientists sometimes learn more about air pollution by studying wilderness areas than cities?
Yeah, of course. So one of the things that I'm working on right now is understanding the different sources of different compounds in Houston. And even in Houston, a large portion of emissions comes from biogenics. so it comes from plants. And biogenic emissions have a lot of potential to contribute to aerosol formation and other things like that, other secondary products. And I would say that, yes, there is a lot of work being done understanding biogenic emissions, how things like deforestation is impacting that, also understanding how forest fires and things like that impact emissions. But yeah, there's definitely a large area of research focused solely on biogenic emissions.
What does it say about our relationship to nature when the air itself carries traces of our consumer products into wild places?
I think you can look at this kind of many ways. As an environmentalist, I'm sure it's concerning, right? And that's worrisome that we're doing that. But just realistically, when we have so many people in the world all using different products, it's kind of inevitable. So I think the best thing that we can do is really understand what the consequences of these different products are. And we have seen that, some may have dire consequences, some may not really have any notable impact. So understanding that and moving more toward the latter in the compounds that we're putting into our products, I think is the big thing that we need to do, because regardless, we will always have some impact in terms of remote air quality and things like that.
That makes sense. Does your research change how you personally think about wild places, wild animals, and the outdoors generally?
Yeah. I think growing up here, we have kind of this really unique but also very biased perspective, because we are able to actually access, these really remote places and be isolated and experience nature in ways that the majority of people never will. And that's something that has been kind of in my past really, shocking when I went to college or things or past that, where, people couldn't really relate to wanting to protect the environment so much because they haven't really been impacted by it. But now seeing that, we really do have this direct effect on all of these places, it really kind of ties that all in together, and I think makes the discussion a little bit easier, honestly, in understanding, how we are actually impacting things, and how, someone living in Houston could potentially be impacting here, and understanding that more interconnectedness, I think, is really helpful, especially now when there's a lot of disconnect between everyone.
If society took air pollution seriously as a threat to wildlife, what might change first?
I think the reality is that first and foremost, we care about ourselves, right? And as a result, we're going to, make the air as clean as we possibly can for us. And as a result, that will obviously benefit other ecosystems. So I think it's a little bit of a frustrating perspective, but again, we see that, it is all really interconnected. And when we understand the impact that our actions on the environment have on us, that really will help shape what we're doing to protect it.
There is some attention paid to water pollution and how it affects life in the oceans. Why do you think there is far less attention paid, as far as I know, to how air pollution affects birds, reptiles, and land mammals?
That's a good question. I think part of that is likely due to instrumentation. And as we're seeing improvements in instrumentation, we're able to measure more compounds at lower concentrations. I think we'll see more of that in terms of air pollution and how that impacts everyone.
I have always been bothered by the fact that humans filter their water while non-humans are left to drink from polluted streams, rivers, and lakes. Do you worry about solutions to air pollution that don't include non-human lives? Is it possible, feasible, acceptable for a city such as Houston, Texas, to fix its most dangerous problems of air pollution while allowing the surrounding rural and semi-wild areas to remain unprotected?
That's a good question. I think that overall, if we're making regulations and bettering, our emissions in the industrial setting, that will have trickle-down effects and will obviously positively impact the surrounding areas as well. The Gulf Coast of Texas is particularly super interesting because you have all of this industry, and then you also have huge migratory bird sanctuaries and things like that. A few months ago, I saw whooping cranes for the first time, a species that was on the verge of extinction and was brought back largely due to measures that were taken in the Gulf Coast area in protecting their habitat. So I think that there is an understanding of the value and importance of protecting these ecosystems and understanding the role that, all of this industry could be playing in those. So yeah, I think that that's not something that's being swept under the rug, and we're not just considering, regulations just so we don't get asthma, but also so that we are protecting, the ecosystems around them as well.
Dystopian image that comes to mind.
It's really weird.
It's like a protective globe over Houston, while the areas outside of the city are minimized or neglected.
Mm-hmm.
Has studying air pollution changed how you think about the planet as a whole? Can your work generate some humility about human control over nature?
Yeah, I think, again, this really shows, when looking more into air pollution, the interconnectedness of everything and how we really have the potential to have impacts, not just in our own communities, but globally, potentially. And yeah, I think that in a sense that really is useful to have that image so that we can not just be, worried about us in our own homes, but also understand that it does affect beyond us.
Do you have any conscious memories or experiences, perhaps early in life, that might have led you to the work you are presently doing? In other words, why have you chosen to study the atmosphere?
Yeah. So, growing up here, we really had a great opportunity to, see all of these natural processes happening. And I was always very curious, why are clouds forming like they are? Why do we get the terrible inversion in the wintertime and have all this pollution in the Grand Valley? Things like that. And then I also was always very interested in, the environmental justice and environmental equity kind of perspectives. And I think working in atmospheric science really, really allows to kind of connect our impacts on the climate and also be introduced to kind of some different perspectives, like these people who live in Houston and are heavily impacted by industry, and understand their perspectives and how they see the world and like their priorities and things like that. So yeah, I think definitely growing up here was a huge shaper of that, wanting to contribute and protect and limit the impact that we have has been big, yeah.
Do scientists have a moral responsibility to advocate for their discoveries?
100%. I think that's kind of a lot of people, scientists, non-scientists, I think that's a big problem, is especially now we're becoming totally, we've lost trust in our scientists. And I think that's largely due to the fact that when you're in science, it's really easy to just get kind of isolated and into the esoteric side of things. And it's really important sometimes to take a step back and reflect on, why am I actually doing this again? And also, how can I explain the importance of what I'm doing to my grandma or to some random person, And that's something that I think needs to be emphasized more in the scientific community for sure is, how do we actually explain this to people in order to actually make something of it? Because, if you're solving this amazing problem in your field, it only matters to a certain extent if you can't explain its importance.
Do you worry about the pressures you face in your career regarding working for corporations in a time of planetary stress and crisis?
Yeah, that's an interesting question. In my field, it's actually relatively common to go into like environmental consulting or work for, these big name like Chevron, Shell, oil and gas companies. And I think to some extent, this is really important. They hire scientists so that they are remaining up to code, they're not getting sued. But I mean, that's a good thing, right? It's good to be making sure that these high polluter industries and corporations are in check. And what I've seen is, like, due to our regulations and our expectations, they also want that. So even in this time where, people are denying climate change and all of this, big companies are investing in employing climate scientists and things to help inform them, where to build new facilities, how to do business, all of these things. So that is definitely a part of the conversation in terms of these big corporations, which I think is good.
Does the ecological crisis carry a burden for young scientists that often goes unspoken?
Yeah, I would say yes. Most people who go into science are obviously going in because they're passionate about something, and you don't choose to be a scientist for the paycheck for sure. And it's often because, you're passionate about improving something or seeing a change in something. But I think, again, we can sometimes lose touch of why it is we're doing what we're doing as scientists, and we can get kind of stuck in the realm of esoteric and forget about the big picture. And again, I think it's really important to step back and remember the importance of all of this.
Is there fear about speaking openly concerning the ecological crisis and the sixth extinction?
Yeah, that's interesting. I don't know if it would be, I guess to some extent it's, discomfort. And it's obviously a hard thing to talk about. And it's not pleasant. It's not a pleasant discussion. But people are definitely concerned about it. It's just, it gets into a matter, I think, for everyone, scientists included, of, what can we do? Like, how can we actually solve this? And yeah, I think that is a cool thing about science, though, and about being in academia is seeing different collaborations in different fields and seeing like how, people, although they may be in a totally different field, do still have kind of a similar perspective and want to improve on a similar thing, like the ecological issues we're having now. So yeah, I think it is just overall a difficult conversation for both, random people in the community and scientists as well.
So it sounds like you think that science can still be a vocation, not just a career.
Yeah, 100%. I mean, and I think that can be seen in many different levels. That can be seen just in, yourself. You can be a scientist sometimes, You can ask questions and research and find out answers. And yeah, a lot of the people who are in science have made careers out of it, but it's because there's an underlying passion for answering questions and learning more about these different areas.
People like yourself are inheriting a wounded world. What personality qualities do you think young scientists need today? I'll give you one if you want one.
Okay,
Courage.
sure. Yeah.
Maybe.
Yeah.
That's
I
one of
think
the
that's
ones
good.
that comes to my mind. Would you agree with that?
I would definitely agree with that. You have to be bold and yeah, kind of advocate for things that haven't been advocated for. So that's kind of scary. And then also you need to some extent, be an optimist in that, you are willing to advocate for these different things because you have hope that there is a reason to do so. It's definitely difficult, but it's also kind of exciting because we do have such an opportunity to make really important contributions, and we can make really important positive impacts, and we do have the potential to do that. So yeah, I think recognizing that there are bad days, but then we do still have room to make progress, and we can do better. Yeah, that's definitely important.
Excellent point. There is so much wonderful scientific information and knowledge available today. And yet one could plausibly argue that there has never been so much unhappiness and unfreedom in the modern world. It must be strange and difficult for young scientists to begin their careers in such an estranged or alienated existential situation.
Yeah. And I mean, as someone who is currently, reaching the end of my PhD, looking to go into the job market, yeah, it's definitely weird times. And yeah, there's a lot of, polarizing perspectives, and a lot of science has weirdly become political, even though it should never have been, right? It's definitely difficult, but I would say that, there are still opportunities, and, people are still motivated and are still doing work. And I think, yeah, it's really kind of a duty that we have as scientists is to really kind of try to fix this dilemma that we have right now in terms of the discourse of discrediting science and negating science and just the really polarizing perspectives we have on it. Yeah, I think it could be seen as very discouraging, or could be seen as an opportunity to really, kind of try to change the way we're looking at things and improve our communication and step away from, the politics of it all and just make it more accessible.
Is there something you wish someone had said to you early in your scientific career, knowing what you know now?
Yeah, I mean, that's a really tricky one because in theory, yes, but I think just to prepare for uncertainty, I graduated undergrad during COVID. I'm now finishing my PhD during this current administration in a climate-focused career. And there is definitely a lot of uncertainty, but also not just in, society, but also in terms of research and things like that. You don't really know you shouldn't necessarily have a concrete idea of what's going to happen and need to be flexible. So I'm sure if I heard that when I was younger, I'd be frustrated because you want more concrete advice and things like that. But I think it's really important to keep yourself open-minded and be flexible and adapt to these really unforeseen changes that we're having, yeah.
What makes studying the air fundamentally different from studying the land or water?
In a sense, there's a lot of similarities. In terms of air quality, I think meteorology really plays a role, and the atmosphere is very large, both in terms of width, but also height. It's very deep, I guess. So what you're measuring at the surface is going to be very different than what you're measuring where airplanes fly. So there's a lot of dynamics and things that play a role in that, and different weather patterns and things can create mixing and all of this. So it's important to be aware of the physics of things and the dynamics, along with just what you're actually measuring with your instrument, to help understand why you're seeing the things you're seeing and the trends that you're seeing.
Is the atmosphere more sensitive to human influence than the land or water, in your view?
I wouldn't say more sensitive. I think each will have their time, I guess, and depending on different types of ecosystems and things like that, you may see more sensitivity in different ecosystems. I think overall, though, the Earth is always trying to be stable. It's trying to reach homeostasis. And that'll be the case in the atmosphere, in the water, in the land. The time scale at which that happens will be different because, like, in the atmosphere, there's much more mixing. Things happen quicker compared to land, for example. But, yeah, I think all of these are really equally susceptible to pollution and things like that, but also equally resilient as well.
No one owns the air, but everyone depends on it. Is the atmosphere the most radical example of the commons that we have?
Yeah, I like that. I would kind of agree with that. Yeah, I mean, we've been kind of having this conversation about how, it's all really interconnected, and that's a great example of it. If you burn a fire in your backyard, that's not just impacting you, that's impacting your neighbors and could impact someone like a few miles away, right? So, yeah, I would say it is a very good example of the commons, because we all are sharing it. Not one person has control over it, and you can't really capture it and have it for yourself at all, or protect yourself from what other people are doing. So, yeah, it is definitely probably one of the most interconnected spaces we have.
We know that there have been attempts to privatize water in Bolivia, Chile, Argentina, and elsewhere. I don't know of any corporate laboratories working, at least at this time, on turning air into a profitable commodity. But would you agree that selling the right to pollute the air is a kind of privatization of the atmosphere?
Yeah, that's a really good point. Yeah, because unlike water, we can't take the air. We can't put it in anything, right? But yeah, having the ability to pollute more than someone else, which does exist, with our companies, I would say, yeah, is very similar to, having privatizing, that resource. Mm-hmm. Yeah, that's an interesting perspective.
Can the atmosphere be effectively protected by systems and institutions built around territory and property?
I would say to some extent, yes. Like, we know that a lot of our biggest contributors to pollution are companies that have addresses and have property, and regulating and enforcing, those areas makes a big difference. But then we've also discussed how the individual plays a role in that. So I think it gets slightly more difficult. But overall, I say yes. We can identify where pollution is coming from. And with that, we can understand its impacts and understand if we do need to make changes.
Okay. How can we make the invisible threat of air pollution feel more immediate and real to people?
World Health Organization lists air pollution as, I think, the second leading cause of premature death in the world. So that alone provides this really, close to home reason to care about this. Mm-hmm. As, we're seeing that it can cause, cancer, cardiovascular disease, asthma, all of these things. And I think most people care about their health, So mm-hmm. I think that's the first way that we can really understand that. And then, I think that's a big thing in more metropolitan areas, but in more rural areas as well. We see that there's increasing forest fires and things like that are also impacting us. And yeah, understanding, the role that we're playing in all of that, mm-hmm. and that it does, in fact, have a huge impact on ourselves is what people need to realize. That it's not just this, mm-hmm. Thing that we're doing that has no consequence, and the consequences do actually really come back to us.
As children, we all drifted with the clouds, and most of us still enjoy the beauty of falling snow. Do such things bear on the scientific study of the atmosphere? In other words, do you think that imagination and wonder still matter in helping people to care about the atmosphere?
Yeah, 100%. I mean, I think that's a huge, important trait of being a scientist is, being curious and asking questions. And a lot of things, in my field are people go down a rabbit hole studying something because, they just think it's cool, Mm-hmm. And yeah, that kind of sense of wonderment and everything, I think, is in everybody, and everyone has these curiosities. And again, scientists can really, I think, do better at sharing their curiosities with everyone else and sharing that and, relating to each other, because I think we all have that in common.
Do you feel a sort of what E.O. Wilson called biophilia? Do you feel that for the atmosphere?
I guess I feel that, yeah, for, the planet in general. 100%. I mean, again, growing up here, I was definitely more thrilled about, nature side of things. And now I'm working more in metropolitan areas and really kind of seeing the human side of things, which is kind of cool. And seeing, how like both of these play such a very interesting and important role in the world. And so definitely have an appreciation now for both, I'd say.
Wise words. You've been listening to Wild Earth Conversations with my guest, Alana Dodero, on KWSI 100.3 radio in Grand Junction, Colorado. More conversations in this series are available at kwsiradio.org or on KWSI's YouTube channel. If you have comments or questions about the show, or if you would like to be a guest, then send me an email. wildearthconversations@kwsiradio.org.